Welcome, Dr. Smith. It's good to have you back.
Yeah, morning, Clarence.
Morning, Clarence.
So let's just dive straight in. Somebody wants to know where exactly does space start? Keith asks the question. He says there's some disagreement about space tourists actually making it to space. Is there an exact space where space becomes space?
Hi, Keith.
Hi,
The
Keith.
answer is no, not strictly, because what's space? Well, space is when we're not on a planet or not on a moon, for instance. But there's not really an agreed definition of, well, what constitutes the space? It's when there's nothing, or there's probably about one atom in every cubic kilometre, or a cubic metre rather, of material or space around us. And that's compared with billions and billions and billions of atoms and molecules when you're within Earth's atmosphere. But where do you decide then that starts? And we don't actually have a strict definition. So what we do have is an arbitrary line drawn, not in the sand, but in the space, which is called the Kármán line, which is 100 kilometres up above the Earth's surface. And once you go past that line, that's where we arbitrarily say, well, space has begun. But it's not true that the atmosphere just stops there and then you're suddenly in this void, in a vacuum. Because even the International Space Station, that's about 400 kilometres above the Earth, periodically has to be boosted to give it a speed up, because tendrils of the Earth's atmosphere reach out, even that far, and they're slowing it down. So it's slowly falling towards the Earth because it's losing velocity to the tendrils of the Earth's atmosphere still out there. So even there, you're still not really in space if you call space the absence of any kind of gases and molecules. So the answer is we settle on this 100 kilometre margin called the Kármán line, but it's not a strict definition because it's really quite an arbitrary one.
Okay, loads of voice notes in. Let's go there.
Hi, good morning, Clarence. It's Flores here from Worcester. Clarence, I would just like to ask the naked science there. I have a mixed pit bull and bull terrier male dog. He always eats his bedding. He will even bite holes in his metal plate. And if he does not get his way, he would pee in the other dog's bucket. And then he knows he did wrong, and then he would lie down with his behind, almost exposing himself for me to hit him, which I don't. He has multiple of toys. Why does he constantly eating up his bedding and biting holes in his metal plate?
Thank you very much. That's a very interesting question. Let's see where the naked scientist takes us.
Well, I'm not a dog psychologist, but I think there are some traits that animals and humans share, and when they display them, they usually display them for a reason. If an animal tears up its bedding or repeatedly rips holes in things, now it might be playing, and I have a dog which has a whole bucket full of toys, and he takes great delight in emptying the stuffing out of, he's got a pheasant because he's a gun dog, and a pigeon or something, some toy pigeon, and he takes great delight in emptying the stuffing out of them, and you stuff all the stuffing back in, and 5 minutes later you turn around and he's done it again, because it's kind of entertaining for him to pull the white stuff out and see it all over the floor. But dogs that do repeated behaviours, stereotypically, they're called stereotypies, where they keep on doing the same thing, which doesn't amount to play, it doesn't amount to any kind of constructive outcome or goal-driven thing, it can be a sign of distress. And there are a range of reasons why dogs can get distressed, other animals can get distressed or stressed. And so it might be something in the environment that's upsetting him, it might be that other animals in the environment are upsetting him, or it might just have become such an entrenched behaviour that he only feels normal when he does that. The biting holes in the metal dish, sometimes it can be because they quite like the fact that they're getting their teeth into something that yields. It's why dogs chew up sticks, and they do it because they clean their teeth that way. It's almost like a toothpick when they grind up sticks and fragment them. They're helping to dislodge muck and plaque and things from their teeth, which keeps their teeth and gums healthier. So there's a range of reasons why this might be happening. I would make sure that the dog isn't stressed in some way or suffering distress from something. It sounds like you're a very caring owner, but amazingly, there can be all kinds of things that a dog finds upsetting that we don't. So have a look at the environment first and see if there's something that's linked to this behaviour that makes it happen and makes it happen reproducibly that might be upsetting the animal. And if you can exclude that, then you could just put it down to bad behaviour.
Let's go to Zuki. Zuki's out in Big Bay. Welcome, Zuki.
Hi, Clarence. Hi, Dr. Chris.
Hi, Zuki.
Okay, Chris, I'm sure you've seen that experiment with the cornstarch in the water where they mix it to become the liquid. And then if you put your fingers through it, your fingers go through. But if you hit it, if you punch it or if you hit it with a hammer, then it doesn't go through. Can you explain how that happens? And also, what would the real life uses for something like that be?
This is called a non-Newtonian fluid. If you mix corn flour and water and make a relatively thick mixture of corn flour and water, you'll get something that will flow around the bowl beautifully. But if you try and pull it or push it very hard, it behaves almost like a rigid stone. And the reason this is happening is that the particles of corn flour are irregularly shaped particles of starch. And each of them is surrounded by a lubricating bubble of water. So when they're all in a liquid state, the water acts as a lubricant, almost like oil, allowing these irregularly shaped particles to flow over one another. And so the non-Newtonian fluid, in this case the corn flour, behaves just like a liquid and it will run and flow. But when you try and push it hard, what you do is jam the particles together, pushing the water out from between them so that lubricating bubble is lost. And now the jagged particles ram into one another and catch. And because they catch, they can't flow like a liquid smoothly past one another, and so it behaves as though it is one solid material in lockstep. And then when you release the pressure, take the force off, the water flows back around all the particles, re-surrounding them. So you're back to that state where they're lubricated and can flow nicely over one another. How does that apply to the real world? Well, it does in situations, for instance, like oil extraction. When we're getting oil and gas and drilling into the ground, to get the rock out of the drill, the engineers will pump the so-called mud, which is liquid and other lubricants, down the drill shaft. This will dislodge particles which are in there and bring them back up. And as they go through the pump, if you were putting enormous amounts of pressure on the liquid like you do with your corn flour, then exactly the same thing would happen and you'd end up trying to pump rock and your pump would break. So you have to take this into account and design pumps that won't do this, and they will apply pressure in the right way or move the liquid in the right way and below the threshold at which this happens in order to avoid destroying your machinery. So that's just one example of that piece of non-Newtonian physics in action. Another good example, bulletproof and stab-proof vests. People are now working on fluids, materials that can, when you have a projectile hitting them, they behave in exactly the same way. So a bulletproof vest at the moment is incredibly bulky, uncomfortable, unpleasant and hot to wear. If you could make a very thin vest that contained these sorts of materials that were flowing over one another easily, meaning you could make something thin and flexible and comfortable to wear, but when a bullet hit it with a big pressure wave, it would make all of the particles lock together like the corn flour, then you'd have something which would protect you from an incoming projectile, but would be much more pleasant as a fashion item and a wearing experience.
Of course, interacting with the Naked Scientist this morning, and you're welcome to ask that question that keeps you up at night, that keeps you awake at night via WhatsApp on 072 567 1567. Your calls on 021 446 0567. We have another WhatsApp voice note in. Let's take a listen.
Hi, good morning. There's a question for the Naked Scientist. I just want to know, I've received a WhatsApp message warning me not to wear socks and a beanie to bed as it will cause a stroke. I want to know how true is that? Thank you. That's for the Naked Scientist.
Socks and beanie? Dr. Smith?
This is a classic case of social media misinformation. And this is one of the dangers of social media, where you have uncurated promulgation of information, sometimes completely fallacious, completely wrong. There's no evidence whatsoever linking socks and a beanie to having a stroke. And in fact, if you go to bed with cold feet, you probably won't have any decent quality of sleep, and as a result of that, you'd be tossing and turning all night and feel really moody the next day, and that will put your blood pressure up, and that certainly will put you at higher risk of a stroke. So the answer is no, there's no evidence of that whatsoever. Otherwise, why would it be different at night compared to during the day? Everyone wearing a hat during the day would be at high risk of a stroke. Well, strokes are common, so by chance some people will be wearing socks and hats and have strokes. because that's what we do. We do wear those items, but there's no reason physiologically why they would increase your risk of having a stroke if you were to wear those sorts of items to bed at night. So go to bed in your beanie and your socks if you're so inclined, and do it with impunity and relax in the knowledge that you are not going to give yourself some kind of cerebral accident.
Let's go to Roger's on the line. Morning, Roger. Welcome. Go ahead for the naked scientist.
Dr. Smith. The first question you had this morning was about space. And I've got a sheet in front of me that tells me that you get the troposphere, then the ozone layer, then the stratosphere, then the mesosphere, thermosphere, and then the exosphere, which is space. Am I right or wrong?
Those are layers defined by the composition of the atmosphere. Ozone layer about 15 kilometres up or so, and then mesosphere and so on. So those are named designated zones, but in terms of where space actually began or doesn't begin, the question was more nuanced because it was about space tourism, and it was people who are increasingly paying for these tickets at very high price actually to go into space and experience what should we say, microgravity periodically. And this is becoming a lot more popular, but people want to be able to say, I've been to space. And in order to say they've been to space, where do they have to say they've been in order to say they got across a certain boundary and were now in space? It's a bit like, where's the equator? If I set foot over it, am I now in the southern hemisphere or the northern hemisphere? It's a line, it's an arbitrary line, which we say, well, that's where we're going to call space beginning. But when you actually say, does it have a scientific underpinning? Can we define that as being distinctly different from 99 kilometres and you're not in space, 101 kilometres, you definitely are in space? Can we really say that? And the answer is we can't.
And thank you for that call, Roger. I hope that answers your question. A question in via the WhatsApp line. Is it true all Inuits never have dental decay, and why is this possible?
You must never say never or always in medicine, because you will always be wrong. And that sentence is the only example of where you can legitimately do that, because there are always exceptions. But there are also interesting exceptions in the human population where people do have higher or lower risks of certain disease outcomes. And they're very interesting to study, because if you have an exception to the rule where people on average tend to buck a trend that you see elsewhere, then they're very interesting to study, because as the old saying goes, nature only reveals her true workings through her mistakes. In other words, you occasionally get a glimpse into the mechanism behind the clock that's ticking, and that mechanism, when it occasionally breaks or changes, reveals the normal workings of that mechanism. So sometimes when we see particular traits in a population that's only in that population, we can then ask the question, why is that? And then we can ask the question, why does that happen? And you can then understand the mechanism. So there will be things in the genetics of individuals, and there are groups around the world for historical reasons, because of human migration patterns, who have particular disease risks or are reduced in their risk of certain diseases. So there will be genetic influences. There will also be environmental influences. People who are in certain environments will be challenged in some ways by those environments, but supported in others. And those environmental pressures will interact with their genetics. So the whole thing goes around in one giant circle. So I don't know whether there specifically is a very low level of tooth decay in Inuits in the modern era, because, of course, no one lives like they did 200 years ago anymore. But at the same time, there may well be historical records of that. There may well be a lower than average rate of tooth decay in some populations. And if there is, that tells you something about the environmental factors and dietary and other genetic factors that might play a role. And that makes them extremely interesting to study, because they're an opportunity to learn and therefore work out how to help other people who don't have that lucky trait to make sure that they have good teeth as well.
Let's go to Barris on the line from Bloberg. Go ahead, Barris.
Good morning, Chris. Yeah, I'm just curious to know, when I go to sleep, I know I'm getting sleepy, but I can't recall the moment to actually go to sleep. So what happens in your mind that actually falls asleep? It's almost like anesthetic. So you can remember counting down, but you can't recall the moment. And also, is it possible to consciously tell yourself to go to sleep?
We've got to put ourselves in the right mindset to go to sleep. When you're driving your car, you are making a conscious decision. I must be alert. I must be careful that I'm aware of what's going on around me. I must not feel sleepy. And if I do, I'm going to take steps to make sure I don't go to sleep. More coffee, take a break, go for a walk, etc. But when we put ourselves in the situation where we want to go to sleep, we're doing completely the opposite. We're taking away all stressors and stimuli. We are turning down the lights, turning off the sounds as much as we can, no music if that's distracting, making ourselves warm and comfortable to the greatest extent possible. These are all things which, from an evolutionary point of view, an animal that feels safe now feels safe enough to go to sleep. So we're making ourselves feel safe and cosy so that we want to go to sleep. When we go to sleep, your brain is putting itself into a state of very much altered brain activity. Your brain doesn't turn off when you go to sleep. Your brain alters its activity, and it alters its connectivity. Different parts of the brain start talking to each other in different ways, and this disrupts your normal flow of consciousness. So you don't have the normal record of what's happening to you with a timeline of, I got up at this time, I did the following, then I did this, then I did this. We have a sequential memory of the day that is time-stamped, as it were. This is all disconnected when you go to sleep, and you cease to make memories in the same sort of way, but your brain certainly isn't inactive. But because you turn off the memory system and you turn off the timeline, you don't remember when you actually went to sleep, although you might remember what was happening just before you started to nod off. Really good way to show this to yourself is find a really boring film to watch, or turn on YouTube or something and watch a few videos, and you will nod off, and you can then work out roughly where you were on the time signature of the video when you nodded off, and then you can see how much you did or didn't catch of the film, and you'll probably find that there was a few minutes which have completely gone. The other way that was explained to me that you can do this to test how sleep deprived you are, actually, it was Michael Mosley, who makes teleprograms and documentaries and things, and we were out to dinner with him last year, and he said a good way of testing how sleep deprived you are is to go and lay on your bed, hold a spoon in your hand on top of a metal dish, and hold the spoon above the metal dish and just sit there, and when you nod off, the spoon will clatter onto the dish and wake you up. And then you'll know when the precise moment when you went to sleep, and you can then work out exactly how much you do or don't remember about that moment and the moments leading up to it.
It's to go to Robin in Edgemead on the line. Welcome, Robin.
Yeah, hi, morning. My question is, might be a bit odd, but I wonder why at supper time can a person always eat bacon and eggs, tomato and toast, and it's delicious. But at breakfast, you don't want to eat like roast chicken and roast potato. Who's telling your body what to eat and when?
I don't know, but the thing is, you can do the experiment on yourself, because if you take a long flight somewhere, so you go across loads of time zones, then you do end up with breakfast time at dinner time, if you see what I mean, and vice versa. And you do find yourself, you're just hungry and you eat anything. So I think it's more a cultural thing that we have decided that breakfast happens and is constituted in the following way at this time of day, and dinner happens at this time of day. So there's an element of that. Also, there are huge numbers of neurons, nerve cells in our guts. Some people say you have more nerves in your guts than in your brains, and we all know people who that is definitely true of. But this means you develop a neurologically programmed bowel habit. The whole sort of point about a bowel habit is that you have trained your gut to expect certain foods at certain times of the day. And your metabolism works like that. You've entrained your metabolism to need certain types of calories and expect certain types of calories in certain amounts at certain times of the day. So there's also going to be that aspect to it, that your gut is expecting to be fed, and be fed in a certain way to a certain extent, as are the microorganisms, the microbiome that live in your intestines at certain times of the day. And this all has feedback effects via hormones on other aspects of your physiology. So I suspect there's a range of cultural and social, as well as physiological and biochemical reasons why we tend to eat certain things to certain quantities at certain times of the day in preference to others. But we can, of course, eat anything at any time. And when you disrupt that cycle, you tend to find people make unhealthy food choices. And if you make people work shift work, for example, and they stay up half the night, then they tend to go for really high calorie, high sugar and high fat, really traditionally what we would regard as unhealthy foodstuffs, because you are basically starving your physiology and forcing yourself to try to get calories however you can. So I think it's all of those factors I've outlined that dictate what we tend to eat, as well as personal preference as the overall choice on top of it all.